So today our lesson is about working with linear patterns. So just to review what a linear pattern is. A linear pattern is a pattern that changes by the same number each time. So something like 2, 4, 6, 8, and so on would go up by 2 each time. The common difference, this number, stays the same every time. That makes it linear. If we were to add 2 and then add 3 and then add 4 and then add 5, that would be a non-linear pattern, which we're not talking about today. We're just working with linear patterns. Okay? So yesterday we worked on finding expressions or equations to describe patterns. And in the beginning, that might seem really challenging, but it's very, very simple for linear equations. You just need 2 pieces of information. The 2 things that you're going to need in order to figure out the expression or equation to represent a linear pattern are the common difference and the zero value term. The common difference, as we just reviewed, is the difference from one number to the next in a pattern. So, as the one we just demonstrated was, it went up 2 each time, so plus 2 is the common difference. The zero value term is the number that would come before the first term. So for example, in the pattern 1, 2, 3, 4, 5, 6, the zero value term is 0 because that's the number that comes before 1. For the pattern 2, 4, 6, 8, 10, we would go back 2 more before plus 2 and we would have 0. So for that pattern, so for this pattern that we're working with, the zero value term would be 0. Okay, so that's all we actually need in order to start working on our expression. So to make an expression, all you have to do is multiply the term number variable, or n, like we talked about yesterday, so the term number you're looking for, by the common difference, and then add the zero value term. So for this pattern that we're looking at right now, 2, 4, 6, 8, 10, that goes up by 2 each time, it would look like this. N equals n times 2 plus 0. And that's our expression or equation to represent this pattern. What's really important to remember is that sometimes we make mistakes when we're doing math. And so you might have this equation and find it really quickly, but I always want you to make sure that you go back and check your work. So the easiest way to check our work for this equation with this pattern is to use some of these term values that we already have. So let's do the third term, 6. So that would look like this. N, in this case, is 3 because it's our third term. So the third term equals 3 times 2 plus 0. And we know that 3 times 2 equals 6. So the third term is in fact 6. Let's try one more to make sure that our equation is right. Let's do our fifth term, 10. So we're going to do our fifth term here. So the fifth term equals 5 times 2 plus 1. The fifth term, 5 times 2, we know is 10. Oh, sorry, this should have been a 0. Look, that's why it's important to check your work. Sometimes we make mistakes. So our zero value term is 0, so I didn't want to add 1. So 5 times 2 is 10. I don't need to add anything. Is our fifth term 10? 1, 2, 3, 4, 5. Yep, absolutely it is. So now that we've done that, we are able to write our answer in words if it was a word problem, or move on to the next question, okay? So this is our easiest way of finding an expression for linear patterns. Don't forget that this is just for linear patterns. I'm going to show you some other tools for nonlinear patterns next time, okay? Have a good day.